Okay, so we're doing essentially derivatives of composite functions today, and we're going to look at higher order derivatives, like the second level and third level derivatives. Those are actually the really easy part. The chain rule is a little bit, I don't know, complicated, takes some practice. Okay, so going back to grade 12, we do composite functions, right? I don't remember doing it in grade 11. So if these are my two expressions, determine an expression for h of x, which is f of g of x. So it's just asking for an expression. So, for part A, g of x gets substituted in where I see x in f of x. So h of x would be 2x minus 1 squared. I could go ahead and expand that. Are you two with me, or are you guys doing your own thing back there? You don't know you with me? You can't even write. You got to pay attention. Okay. So that's really easy peasy. Doing that stuff is all grade 12. You guys have done this a million times. If we were to evaluate that, so f of g of x, so I've got the expression. All I have to do is substitute in -1, whereas the too many brackets. I gotta explain it there. All right. So -2 minus 1 is -3. -3 squared is a positive 9. Good with that. I skipped a bunch of steps today, so you can do that in your head. Easy peasy. So another one, just again from grade 12, h of x is f of g of x. So this is going to go in where you see x. So now for h of x, it's going to be 1 over 2x minus 1 squared. You guys can do this in your sleep, right? And then if I were to evaluate this expression at -1, super easy, because we already did this. We know that that's positive 9. So h of x, h when x is -1 is 1 over 9. That's super easy, right? These we did in grade 12. Define f of x to express y equals root x minus 1 as a composite function, where f is g of x. You did these in grade 12, where I gave you the composite function. Now I'm asking you to break it down into the two functions. So what would give me some ideas? There's not just one correct answer. Ideas, but there could be potentially more. So this given is your composite function. This given is your composite function. That's the already one combined. So what would be the two individual functions? One would be root x. So root x, and then what would the other one be? X minus 1. Now, you're right, but which one belongs to what? Which one's f of x and which one's g of x? This is f of x. And so this one must be g of x. You guys did this in grade 12. You all said you didn't like them in grade 12. They're not terrible. So here's another example, giving you a composite function. Here's your composite function. What are the two? What are your two original functions? So f of x is x cubed, and g of x is 2x plus 1. There's not really any math you have to do there. You just kind of have to look at it and pull it apart. Okay, so now we're we're talking about differentiating a composite function. And we have to do that using the chain rule. I'm sure you're super pumped. Okay, so the derivative of a composite function can be summed by A, simplifying the original function before differentiation, or applying the chain rule. This is the chain rule. So if you want to do the derivative of the composite function, then you take the derivative of f of x, so you've got to be able to pull those two things apart. Derivative of the f of x of g of x times by the derivative of g of x. Right? Makes sense? Perfect sense. I'm sure that's pretty easy. Look at that, we got through 2 of 7 pages. It'll make sense as we go through. All right. So this says to expand, simplify, and differentiate. So this is option A that I said. So the idea is to get it out of composite function form and into just an expanded polynomial. Because then you can apply just differentiation rules. Not so exciting because this is a cubed. You guys can all do this in your sleep, right? I'm going to run out of room. That's a 2. I'm just going to combine these just for simplification's sake. I haven't even differentiated yet. I've just expanded. Now they combine like terms. That's 6x squared plus 1. I don't know why you can't read that. I think when I get too far away from the bar, it gets upset with me. 1, 2, 3. All right, so now that we have it out of composite function form, and we have it in just to a polynomial, now you can use your basic differentiation rules. Easy peasy. So what's the differentiation rules? So this is going to be 27 on the outside, 6x to the exponent 5 on the inside, plus 27 on the outside, 4x cubed, plus 9, 2x. What happens to the 1? 0. So if I do all this multiplying, 162 x to the exponent 5 plus 108 x to the exponent 3 plus 18 x. So not terrible, just a lot of math and a lot of potential to make some easy mistakes. So this is kind of like going back to your table of values. If all else fails and you don't know the chain rule, you can actually expand it. It's going to run into problems when you are not a big fan of turning x to the, like if this was to the exponent 5, this would become a lot uglier and longer and not necessary. Okay, so now we're going to use the chain rule to do the exact same thing we did up here. Okay, it's a composite function. So first of all, I got to find my g of x and my f of x. That's why that's important. So what's my f of x? Okay, what's my g of x? If you struggle with that part of the chain rule, it's going to be really difficult. Okay, so I need to find the derivative of f of x, 3x squared, that's not hard, and the derivative of g of x. I get so excited to write 6x, I forgot my equal sign. So that's not very hard. So the first part of the chain rule says you're doing a composite function. You're taking the derivative of f of x and you're putting into it what? The original g of x. Okay? So this would be, the derivative of this is going to be 3x squared plus 1 squared. Right? Because I took the original g of x and put it inside the derivative of the f of x function. And then what are we going to multiply that by? The derivative of the g of x. So all you have to do is expand, which I'm sure you're really excited about. Can I multiply these two? Are you guys going to be okay with that? If I do that right up front? Or do you want me to do it in order? You don't care? Perfect. So 3 times 6x is 18x. I'm just going to get that multiplying the monomials out of the way. And that's going to be times 9x to the exponent 4 plus 6x squared. What? Yeah. So 18 times 9 is 162. X to the exponent 5. 18 times 6 is your 108. X to the exponent 3. And this is going to be plus 18x. So to me, that's a lot less work than option 1. And there's a lot less multiplying for me to screw up. You get the exact same answer, it's just how much work you want to do to get there. And then some of them are really nice, and like this one we're not going to simplify. It's an exponent of 5, we're not going to simplify it. Okay? We're not going to simplify either on the page. So you're not going to simplify unless instructed to. That was kind of like the product and the quotient rule. Unless it specifically says simplified, don't do it. Right. So what's f of x? What's f of x? X to the exponent 5. G of x. 6x minus 1. So the derivative of f of x is going to be 5x to the exponent 4. The derivative of g of x is simply going to be 6. Easy peasy. So what's the first part of the derivative of the chain rule? This, that into f of x derivative. So we're going to have 5, 6x minus 1 to the exponent 4 multiplied by the derivative of g of x. Just leave it. I don't want you to simplify. Again, in calculus, we do a lot of stuff with our calculator. So, I mean, you could get fancy pants if you wanted to. Crazy, I know. All right, so I'm going to hit pause. Do I want to pause? I don't want to hit pause. Okay. This is what I would do for this one. Is if it's 1 over something, I would change that to a negative exponent. It's going to make your life a whole lot easier to be a negative exponent than a rational. You can put it back in the a rational expression once we get to the end, but I wouldn't do it. And we're not going to simplify this one either. All right. So what's f of x? Yeah. If you aren't certain to see it, that's what I'm talking about. And put it into a negative exponent would be x to the exponent negative 3. And then the derivative for this is going to be negative 3 x to the exponent what? Negative 4. That's a really easy spot to make a mistake, turning that to a negative 2, but you're subtracting the 1. And g of x is 3x minus 2, and the derivative of g of x is okay, so knowing that, can you guys finish the chain rule? To leave your exponents as positive. But unless I specify it, you wouldn't get deducting marks for reading it like that, but you should know what this looks like. All right. Easy peasy. What does that mean? Yeah. Essentially, you're taking the derivative of this function, independent on the bottom, dependent on the top. It's nothing different. It's just the notation. I haven't used it very much so far, but you're going to see it in different things. So I thought I'd throw one in for funsies, because I know you're super excited about doing that. All right, let's do this nice and quick. Can we do it without? Can we do it without doing the side note? Yeah, I think I can. So derivative, the first function would be 4x cubed. The derivative of the first function. So the first function would be x to the exponent 4. If I took the derivative of it, it would be 4 to the exponent 3, right? What is my second function? My g of x. 5t plus 6. And then what's my derivative of this function? Just 5. Now, if you don't feel comfortable doing that, I'm not worried about that. So you don't have to go and do that. You can use your side notes. I just thought we'd try to get something easy. times. So since that's really easy, we're going to combine the chain rule and the quotient product rules. You ready? Awesome. Okay, so where's my composite function? Hello, anybody? Everybody's on the phone. The first one is my composite function, which will require the chain rule. So what I would suggest is you do that first. Okay? So I'm going to call that h of x is equal to 3x squared plus 2 to the exponent 5. So now I'm going to ask you to apply the chain rule to that. Let's break it down into steps just so you can see everything. So my first function here, my f of x, is going to be what? X to the exponent 5. And my g of x function is going to be 3x squared plus 2. My derivative of the f of x function is going to be 5x to the exponent 4. My g of x function, my derivative of my g of x function is going to be 6x. So now, what is the derivative of h of x? I'll show the derivative once. You guys good with that? So all we did was apply the chain rule. So remember, do you guys remember the product rule? So the product rule was h prime of x is equal to original function f of x times by derivative of g of x plus original g of x times by derivative of f of x. That's the product rule. All right. So we have the original h of x. We now have the derivative of h of x. We had to use the chain rule to find it, but we have both of those. So now we are going to look at our second one. This one here, we're going to call, I don't know, what do you want to call it? Let's call it k of x. I'm just feeling special today. 2x cubed plus 5. What's the derivative of that function? About 6x squared. And is a cube, right? I just screw that up. So now that you have original function, differential, original function, differential, now you can do some product rule. So the product rule says, whew, I don't even know where I am anymore. Okay, so I've got y prime. We gotta switch colors. So y prime is your first function times by the differential of the second one. So the first one is this one times by the 6x squared. Times by 6x squared added to the k of x function original, which is, what's the k of x function? Scroll up too far. 2x times by the differential of the second one, which is 30x times 3x squared plus 2 to the exponent 4. I'm not going to ask you to simplify that. So that is your differential of this equation. So it's taking all of the rules that you think you know or probably know. All right, now give me your quotient rule. Do you guys remember the quotient rule? Yeah. So h of x, and then it goes g prime is normal g. G of x times f prime. And subtract f of x. G prime of x all over so that's your quotient rule. That's your quotient rule. So your composite function is your numerator. Your composite function is your numerator. So we have to apply the chain rule to it. So go forth, children, and apply the chain rule to the numerator. Good? Chain rule? Did you do it? Because that should have been your answer for the chain rule. Bless you. Bless you. It's supposed to be 3. 3 seasons, that's the rule. Okay, so now g of x is my denominator, and that's 2x squared plus 4. So differentiate that, it's going to be 4x. So now, to do the whole quotient rule, you got to put it all together. So the whole quotient rule says start with g of x. So if I start with g of x, that's going to be, so this is, I'm doing the differential of the whole thing. So start with g of x, that equation is 2x squared plus 4. That's multiplied by the derivative of f of x. Order matters here. So you have to do it in order when you're doing the divide questions, because it's a subtract. And then we're going to subtract the original f of x function, which is 3x to the exponent 4 plus 2 to the exponent 3, times by the derivative of g of x, which is 4x, and that's all over the original g of x function squared. Do you want to simplify it? You could if you wanted to. simplify it, yeah. So these chain rule and quotient rule, product rule are all on your formula sheet. So you should be okay to do that.
Wow.
Boring. Sorry. All right. Here's the thing. The second derivative represents the slope of the first derivative. What does the first derivative represent? The slope of the curve. So it's the slope of the slope. That's fancy. Okay, so here's what you need to know. All the rules apply. Like, so we found the derivative of y. We can now do the second derivative of this as if it were the original function. That makes sense, everybody? It's really easy. Higher level derivatives don't take any extra knowledge. This is what you need to know, though. Displacement is the original function. So when we talk about displacement, that always is referring to your original function. Velocity, if we refer to velocity, that's your first derivative. Acceleration, that's your second derivative. Your second derivative is simply the derivative of the first derivative. Make sense? Easy peasy. So if you have the original equation, you differentiate once, you've got the velocity. You differentiate again, you've got acceleration. And then a jerk motion, or just simply being a jerk, is your third derivative. So essentially, in physics, if they ask you to find acceleration, you can find the second derivative and solve it. It works. So we shouldn't do this? Come on, it'd be good times. I love it. Everybody's for that. All right. Easy peasy. It's asking us to find velocity, acceleration, and the jerk. And the jerk. Okay, things are going to get big, and I left you a whole page to do this. All right, so this is your displacement. Everything is working off that original function. You have to recognize the composite function right away in order to do your chain rule. So if we are going to find velocity, that is my first derivative. So that's going to be f prime of x. I know I'm going to require a chain rule. So it's going to be 3 4x squared minus 3 to the exponent 2 times 8x. So 24x 4x squared. Oh, forgot my x. Okay, so now chain rule is easy, right? Nothing's hard, it just gets a little bit more complicated. All right, so now we're moving on to acceleration. So acceleration is we're going to have to take the derivative of this. So what do you see in there? What do you see in there? I see a composite function and I see a product. Did you guys see that? So I've got my composite function here, and because these two things are multiplied, I also have to apply the product rule. It's only going to get more complicated because we're going to do this one more time. Okay. So we're going to take the second derivative of this. All right. Let's refer to this as h of x. Let's refer to this as g of x. So if my d of x function is the composite one, you guys can do chain rule in your sleep, right? Kind of. Yeah. So if we said the h of x function is 24x, h prime is just 24. Okay, so if I have this done, and now I just have to apply the product rule. So the product rule states first function times by the derivative of the second function. So I'm doing the second derivative, so I'm still calling it f double prime of x now. So I'm going to say, what am I going to say? First function was 24x times by the derivative of the second function, which is this one. So this one is 16x times 4x squared minus 3 plus this original function, which is 4x squared minus 3 squared times by the derivative of the other one. Can you get that? I'm just going to multiply these two things together because it's going to help us in a second. I'm just going to do any simple multiplying that I can. 24 plus 16, 384 x squared. 4 squared minus 3 plus. Do you want to multiply that in? All right, so now you found the equation for acceleration. Are you ready? Now we're going to do the jerk motion. This is a jerk. This really does feel like it's a jerk. Okay. So we have two product rules. Are you ready for this? So there is my first one. We're going to have to do the product rule off that one. So what is the derivative of this one? Right? What's the derivative of that one? Oh, you're right. Sorry. I I just got excited and I just wanted to do the exponents. 768. Did I get the AX right? Yeah. Okay. So now we have to do the product rule for this one. So what's the product rule say? First one, 384x squared times by the derivative of the second one plus the second function times by the derivative of the first function. Okay, so that's the derivative of this one. We can actually multiply that in and make that. Those are two monomials. Multiply, that might be helpful. No? Okay, never mind. We'll wait. We'll wait. I don't want to rush these things for you. Okay, so what's the derivative of 24? What's the derivative of this one? The chain rule. Opposite function. So 2, 4x squared minus 3 to the exponent 1 times by 8x. So now we're going to have to do the product rule of this one. You're like, but there's a 0 in there. What do I do? Yes, one side will be gone, but the other side won't. So let's do the derivative of this. Change product rule. So it says take the first one, multiply it by the derivative of the second one. Yes, you will end up adding them because it's added here. 16x times 4x squared minus 3. And then that's going to be plus the first function, which is 4x squared, or the second function, sorry, 4x squared times by the derivative of the first one. What happens to that? It goes away, right? Like it's just 0. I'm just going to clean some stuff up because we're going to make it look nice. So now we're going to do what we can to combine like terms. Are you guys okay with that? No, I'm not. I'm not going to. Do you want to combine like terms or do you want to just leave it the way it is? I love it. Okay, so my derivative, my jerk function derivative, is going to be this. It's going to be these two things combined, these two product rules combined. So 384 times 8 gives me 3,072 x cubed. All I did was multiply those two things together. Now I'm going to multiply this into here and into there. So 768 times 4 is going to give me plus, sorry, 3,072 again. X cubed. Oh my goodness, there's two of them. Minus 2,304 x. Now we said that this went away because it's times by 0. (24 times 16 is 384. 4. So this times that gives me positive 1,536 x cubed. Subtract 24 times 16 times 3, 11, 52. Combine like terms. All right. $7,680 x cubed minus 3,456 x. That is my equation for the jerk motion. Kind of that's supposed to be F got F. All right, that's it. So if I ask for acceleration, you need to know that you're finding the second derivative. If I ask, and it gets more complicated because you're doing more things than all that. Everybody